Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, let's begin our class with Ummul Kitab Al-Fatihah. Bismillah. Okay, thank you for joining this class morning. This morning class. Okay, so today I just want to give a brief introduction lah on the UAV image processing. Okay, I know most of you has played around with the UAV image processing software. Okay, so I just want to make sure lah, everybody have the same page lah. So I don't want to let's say five of you only the expert in the UAV image processing, then the other 15 are quite blur what is the image processing. Okay, so let me brief. So actually you have learned about the image UAV about the image processing in advanced photogrammetry. Okay, so let's begin. Let me share my slides. Okay, so UAV image processing. Okay, so maybe some of you until now doesn't heard about the structure from motion software. Okay, so if you heard about SfM, okay, SfM is for structure from motion. Okay, ataupun it's already known last time called as the automatic aerial triangulations. Okay, in photogrammetry and in advanced photogrammetry, okay, you have learned about the automatic aerial triangulation in I'm not mistaken in topic number 3. Okay, so you have learned about the conventional aerial triangulations, and then there's some introduction on the automatic aerial triangulation, that's AAT. Okay, and then the AAT also known in the open market, they also known as the structure from motion software. If the people ask you what kind of SfM software that you use, so you just mention lah about the Soft ke, P4D ke, ataupun photo mode UAV ke, apa lagi yang you buat tu, Bentley ke, so there's many SfM software right now lah. Okay, so it doesn't matter about the name, even SfM ataupun AAT. Okay, so this is the innovation in image processing. So we no need to identify type point by manually. Okay, so you have suffered during survey camps. So during survey camps, I want to teach you how hard the computer trying to find your punya type point. So that's why. So if we find, if we perform our manual image type points, so it will the result the products will have the high accuracy lah compared to the computer programming. Okay, because our skill more advanced with the computer lah. But most of the people want to save time and get lazy time to time. So that's why they create ataupun develop the automatic aerial triangulation ataupun structure from software. So this is the conventional photogrammetric orientations. So this is my bear in your mind. So this is the four processing stage in photogrammetry. First is about interior orientations. Everybody can hear me kan?
Boleh, Doktor.
Alright.
Boleh,
Okay.
Doktor.
So alright. Okay, thank you. Okay, interior orientations. So interior orientations, what is the purpose of interior orientations? Okay, but sebab apa? So maybe some of you lepas ni you want to become the pioneer at any private company ke ataupun apa. So maybe you akan masuk tender. So you need to represent your punya company. So you need to represent your company and then to bid for the tender. So you must know lah this stage in photogrammetry first. If you have the strong fundamental, then it's no problem for you to justify lah during the bid presentations. Okay, and then what is the interior orientation? Okay, interior orientation. Okay, we use the camera parameters. Okay, in to correct the internal geometry of the image. Okay, that's the purpose of the interior orientation. We need to correct the internal geometry of the image based on camera parameters. Okay, maknanya that's why you use the let's say you insert the focal length, the principal points, and then the lens distortion, tangential lens distortion, radial lens distortions, affinity scale factor, you insert in the interrogations, then all the internal all the camera parameters, okay, will correct the internal geometry of the image. Okay, and then after we complete with the interrogations, and then we can proceed with the relative orientations. Okay, relative orientations means, okay, to perform the image matching. Okay, so it's based on the stereo model. Okay, so in order to get the stereo model, so you must have at least two overlapping images. Okay, so you have two overlapping images, then you will find the tie points between the two photos, which is overlap. Okay, so last time so we can perform manual tie point manual tie point identifications, ataupun we can use the automatic tie point ataupun automatic tie point image matching lah. Okay, and so after we complete with the relative orientations, then we proceed with the absolute orientations. Okay, absolute orientation, we need the GCP, ground control points. Okay, we need ground control points in order to perform the absolute orientation. So absolute orientation, okay, the purpose of absolute orientation is to transform the image coordinate system to local coordinate system. That's why we use GCP, because GCP represent the local coordinate system. So when I said about the local coordinate system, what are the example of the local coordinate systems? Anyone?
Kes sini ni.
Apa?
Local coordinate system
Ah,
kes sini ni.
kat sini Sokner lain?
GDM ke, Doktor?
GDM lain?
Atau RSO.
So okay. So that's the example the coordinate system that you use in Malaysia so that, kita tengok nanti. Okay, so when you bid a tender nanti kat luar nanti kata represent your company, so you kena tengok spec dekat you kena check the spec in the document tender. Okay, kalau dia kata okay, we need the output in geocentric datum. Okay, sekarang ni ada MyRTF lah apa lah semua benda. So you kena tengok lah, and then you kena produce based on the coordinate system in the spec tender lah. Alright, so that's the purpose. Okay, that's why we use the GCP in order to transform the image coordinate system to local coordinate system. Okay, dah record kan? Dah saya record dah. Okay, dah. Alright, so then after we finish, okay, after we complete with the absolute orientations, okay, and then we can perform the aerial triangulations. Okay, what is the aerial triangulations? Okay, aerial triangulations, okay, is to triangulate between the 3 points so the name of the aerial triangulation pun kita dah tahu. Okay, is the triangulation. Okay, is a triangle. Is a triangle between the 3 points. Okay, so the purpose is the aerial triangulation to create the surface of the terrain ataupun building ataupun apalah. Okay, that's the purpose of the aerial triangulation. So, but in aerial triangulation, we also perform the bundle adjustment. Okay, bundle adjustment. What is the purpose of bundle adjustment? Okay, the bundle adjustment is to distribute the error distribute the error evenly throughout the model. Okay, that's mean kita bahagikan error tu sama banyak. Kita buat adjustment, bila kita buat adjustment, kita akan kumpul the error at the hujung. Macam you do any adjustment in surveying, let's say you use transit method ke, bodice methods ke, so you carry the error at the end of the stations kan, and then you distribute the error throughout the traverse line. Same in photogrammetry. Okay, after you create the error triangulations, and then you adjust for each lines for each triangular line tadi, triangle lines tadi, you adjust, so it will distribute evenly the error throughout the model. So that's the purpose of the bundle adjustment. That's why we call as the bundle adjustments. But okay, in photogrammetry, we have three types of the adjustment. First, we have the independent strip. Independent stereo pair. Independent stereo pair. And then we have the independent strip. And then we have the block. Okay, so independent stereo pair, that means it's only perform the adjustment on the stereo model only. So independent. So it's correct. Adjust the stereo model number 1, and then we proceed stereo model number 2 until the end lah. So it's adjustment individually based on the stereo model. Okay, but the independent strip, so let's say you have 5 strip. Okay, so adjustment will proceed first strip first. Okay, so it's will adjust first strip. Okay, then done, and then it adjust second strip, done. So the first strip and second strip is not dependent lah. Okay, it have the different adjustments. Okay, but the block adjustment, okay, let's say you have 5 strips, so each strip have let's say 25 images, so it will perform the adjustment based on the all strips and all images, right? On all stereo model and all strips. That's what we call the block adjustment. Okay, so you must understand, okay, the terms in adjustment. Okay, so this is the photogrammetry annotations. This is the only dia orang cakap apa revisions and you have learned in advanced photogrammetry. Okay, so what is SfM software? Okay, SfM software. Okay, SfM software. Okay, so there are many software available in the market using AAT or SfM. So bila you grab after you grab you go to any company and let's say you attach with the drones company, so they will call as the SfM software. So that's why I give you a task the projects in order to explore so many various types of the SfM software available in the market as least bila you keluar, you know, this is this kind of the software that which can be used for the UAV image processing. Okay, so kalau I teach many software, so it doesn't give any impact to you. If you do, if you did your own project and then you process and then you write a manual, so then it will enhance your skill in processing. Okay, so SfM Alright. So this is one example. So this is the two. I'm not saying this is the two top software. So because we have the many competitors right now, so this is the common software that we use for the AAT ataupun SfM software in the university. Okay. So Agisoft. Okay. So these are the steps in ataupun these are the stages in the Agisoft software lah, especially for the aerial image processing. Okay. Let's see. Pointer. Okay, so aerial. Okay, airline image. Okay, what is the purpose of airline image? Okay, airline image. Okay, is IO. Okay, interior orientation. Okay, so in airline image, okay, they have many options Okay, so I will demonstrate to you later Okay, so this is we just need to know about the processing first at the stage of in the image processing in Agisoft software. Okay, align image, that's mean it's actually it is interior orientations but they use the term align image. And then build then cloud. Okay, build as cloud is RO. Okay, this is our RO. Okay, and then build mesh. Okay, build mesh. This is AO Okay, AO. Okay. Okay, and then so on. Okay, this is together lah. AO. Okay, build mesh and build texture. Okay, so we have the align image, build dense cloud, build mesh, build texture, create DEM, generate DEM, and then autophoto. Okay, and then so I just want to make sure you can relate the photogrammetric orientation and the SfM software. So align image, we use all input the camera parameters and to with the onboard GPS positioning. Okay, to align the images. Okay, let's say you have 2,000 images, then you can align 2,000 image lah. Okay. Okay, then RO, build dense cloud, that means you perform the image matching. Okay, this is what we call build dense cloud. And then build mesh, you create the area triangulations. Okay, build texture, same lah. Okay, so build mesh, dia buat the rough triangle, and then build texture, we have the most triangulations lah. So it's used the GCP in order to do the bukan GCP lah. They use actually they use some kind of the position from the interior. So they use the they generate the aerial triangulations in the stage build mesh and build texture. Okay, then it proceeds with the DEM and orthophoto. Okay, this is the step in ArchiSoft lah. The basic step in ArchiSoft. Okay, any question in this stage?
Doktor, kalau macam build apa dance cloud kan, kalau terus pergi DM ada isu ke?
Okay, kalau dia pergi terus DM, so dia akan dia mesti ada build mesh dulu. Kalau tak pergi build texture tak apa, dia mesti ada build mesh. Pasal apa? Build mesh ni akan create dia punya triangle dan akan create the surface of the terrain tadi.
Sebab macam ada software macam Global Mapper kan, masukkan point cloud, dia jadi DM terus.
Okay, point cloud. Okay, itu point cloud. Okay, dekat dalam Global Mapper, dia adalah software yang create DM daripada spot height. Okay, nampak tak? Okay, dari spot height. So memang spot height, use even CDS pun you boleh create DM, ArcGIS pun boleh create DM. Tapi dalam behind masa dia nak create tu, dia akan buat TIN, Triangular Regular Network. Perasan tak? So triangular regular network tu adalah build mesh. Nampak tak? So dalam GIS kita panggil TIN. Tu dalam GIS. Dalam photogrammetry kita panggil AT. Nampak tak?
Faham betul.
Dia akan lalu ni salah satu ni benda yang sama je lah. Nama je berbeza pasal different field kan. Lepas tu baru boleh create DM lah. Boleh
Tapi masih boleh doktor kan kalau macam pakai software lain untuk buat DM lah.
Boleh, tak ada isu. Boleh. Sebab sama, software lain pun akan terlalu ni, dia akan pergi DM balik. Pasal apa? Nak create surface, digital surface model ataupun digital elevation model. Nak create surface ni, kita mesti ada dia punya rough surface dulu. Dan baru kita smoothkan pakai DEM tadi. Alright?
Okay, baik. Terima kasih doktor.
Okay, lain tak ada Okay, kita move.
Doktor. Kan masa buat apa dense cloud tu kan, sebelum ke mesh, kita perlu ke macam buat classify dense cloud tu macam untuk dapat accurate data masa generate DEM ke apa ke?
Classify apa?
Dense cloud.
Classify dense cloud. You classify dense cloud untuk differentiate ground, differentiate vegetation apa semua kan?
Ya betul.
Betul. Okay, betul lah. Kalau you ada specific application and you nak keluarkan, contoh you nak keluarkan DTM ataupun DEM, and then you can classify lah. You can classify, you click ground saja. Dia ni sama konsep dengan LiDAR data lah. So they have the 17 classes. Okay, kalau you tu, dia you kena classify build dense cloud dekat step yang satu lagi. Okay, you classify and then you select only ambil ground saja, you tick ground, lain semua untick, and then baru generate DEM. Boleh untuk dapatkan lebih better data, lebih elok lah. Kalau kata you nak buat DSM, Digital Surface Model, you tak perlu buat classify ground tadi. Okay?
Okay, terima kasih.
Sama. Lain tak ada Alright. Okay, we move to next software lah, Pix4D. Okay? So this is the same, structure from motion software juga, using the AAT. So actually it has compiled the step in one stage lah. Okay, for example, for the initial processing. Okay, same. This is I/O. Okay, this is I/O. Okay, initial processing, they use the GPS on board and then they insert insert the camera parameters in the aerial images. Okay, so they perform the I/O. Okay, and then point clouds and mesh. point cloud adalah spot height yang macam ni cakap tadi lah. Tapi ni point cloud adalah apa tu? Outcome from the image matching. Okay, this is what we in episode they call as the point cloud. And then mesh same lah. This is AT. So this is RO. Okay, this is RO and AT. Okay, so sama So in episode they compile. So they compile image processing in IO and then point cloud and mesh in one stage lah. So RO and AT, and then they produce the DSM auto and index. Okay, so maknanya I want to make sure you can relate the AAT ataupun SfM software with the conventional automatic processing lah. So these are the same things but they use the different term. Kalau you tengok in this apa Agisoft, they use the terms dense cloud. Kalau you tengok dalam Pixody, they use the point cloud. This is the same things but different terms saja. So mesh sama lah. Kalau you tengok mesh sama. Okay, any questions dekat Pixody? So I know most of you have used the Agisoft and Pixody. Tak ada Okay, kalau tak ada, okay. Kalau untuk 3D model, kalau untuk POI, for the POI, okay, the previous slide and then the second previous slide, for the aerial image processing, okay. But the 3D model, okay, they have one extra stage, okay. They call as the build type model, okay. So the other step is almost the same lah. So build type model ni maknanya dia nak tile the model for the 360 so because 3D model the way you capture the image pun is different from the aerial image Okay, the aerial image you use another angle, but the 3D model you use the oblique method. Okay, so they have the processing. So in Agisoft atau in Agisoft they have one extra module they call as the build type model. Okay, so the only the different between the 3D model and aerial model. Okay. So before I forget so make sure you after this you fill in you punya SOFO and EES lah dalam you future nanti tarikh tutup nanti you terlepas lagi SOFO and entrance exit survey. Okay,